Woohoo, welcome back. We're back to finish the problem that I started. I had a small technical difficulty with my computer. I hope it's fixed now. I'm really sorry. That stopped right in the middle. And so I know you are all very excited. You're like, wait, what? What do we do? So let's finish this completing the square problem. So let's review. What did we do? I took the x's and I separated the x's out, just the x's. I factored the 9 out and I created a little cubby inside the parentheses to complete the square. Then when I realized the number I wanted to stick in there was a +4, I can't just put a +4 in. So I put in a +4 but immediately subtracted 4. So the net result is that there was no result. Right? I didn't add or subtract, but I'm just using a trick to allow me to add 4 here, but then subtract the 4. But I can't just subtract 4 because there's a 9 outside, so I have to subtract 9 times 4. Okay, this is getting exciting. 9 times 4 is 36. So I've got this piece, and then plus the 4y squared. Now, this happens to be a perfect square. And here's where you have to have some faith, because these problems do work out. They just feel a little bit stressful in the middle. I have this -36. It's in the way. I got some x squared, some y squareds. I don't want this here. I'm going to add it so that I get rid of it. So then I've got 9 times the quantity x minus 2 squared plus 4y squared equals 36. And I will grab another sheet of paper so that I can continue on. 9 times the quantity x minus 2 squared plus 4y squared equals 36. Okay, what has happened? Well, I've taken that initial problem where the x's were multiplied out, and I've tucked them back in together. So now I can read this as a shifted conic section. You can see I've got x minus 2, so hopefully your brain is already thinking, wait, if I'm subtracting 2 in the x direction, what is that going to do to the ellipse? It's going to move it 2 over to the right. So we've got a shifted ellipse. Woohoo! So how do we proceed from here? So what we're going to do is we're going to divide everybody by 36. Why 36? Well, I want a 1 over here. So whatever's over there, I'm going to divide by it and hope that I get something nice. You don't always, but a lot of the time you do, so you can always hope. As it turns out, 9 times 4 is 36. So we got very lucky. What are the chances? Woohoo! And that's our shifted ellipse. Now, what does the problem ask? It says complete the square to find the center. So the center basically means instead of, so who's bigger? Let's look, the x's or the y's? Whose denominator is bigger? The y's. So this is going to be our, yay, it's his day, it's Spider's day. So basically we normally would have an ellipse centered around 0, 0. And if we're looking at the major axis, right, this is 9 is 3 squared, 4 is 2 squared, so this would be up at 0, 3, down at 0, -3. This is over at 2, 0. This is over at -2, 0, right? So that's our center at 0, 0. So this would be what would happen if we had x squared over 4 plus y squared over 9 equals 1. So that's centered at 0, 0. We don't have that. Ours is offset by 2, right? X minus 2. So that means that to get to this new center, we are transforming it, since it's x minus 2, the new center is going to be at 2, 0. The whole thing is going to shift over to the right. So here's going to be the shift. Our new center is at the point 2, 0. And now I'm going to have a vertex here at 0, 0, because this point moves over 2. I'm going to have a new vertex at the point 4, 0. You see that? The negative 2, 0 went to 0, 0. The 2, 0 goes to 4, 0. The 0, negative 3 goes to 1, 2, 3, 2, negative 3. And the 0, 3, 1, 2, 3, goes to 2, 3. So that's all that happens. And I drew it on, this one ended up being slightly small because I wasn't being as careful. This one I'm being a little bit more careful. It ends up being a little bit wonky. Sorry about that. But the new center is at 2, 0. Now, if it had been x plus 2, we would have gone to the left. So we'd center it around negative 2. If it had been y, then we'd move it either up or down, depending. Okay, so what did it ask? Complete the square to find the center of this ellipse. We found that the new center is at 2, 0, right there. Yay, we did the first part. Then, using the ellipse with the center at the origin, find the foci and shift them to find the foci for this ellipse. Okay, let's do this. So, in this case, a squared is 9, b squared is 4. So c squared, which is a squared minus b squared, the bigger one minus the smaller one, 9 minus 4 is 5. Okay, so c squared equals 5. And so that means that we've got foci that are up here at 0, radical 5, and down here at 0, negative radical 5. Now, how do I know they're on the y-axis and not the x-axis? And the answer is because the major axis is the one, y is over the bigger number. Whichever is the bigger denominator, that's the axis that wins. So now what happens when we shift this 2 units to the right? Our new foci will be here-ish at the point 2, radical 5, and here at the new point 2, the opposite of radical 5. Woohoo! Now this was a lot of work. I'm not surprised that my computer broke down when I asked it to record all of this. So 2 examples, probably not enough. So please ask for lots of help. Talk to the tutors, talk to me. This takes a couple times. And the goal is that if you do this work now, when you come back to these shapes later on in calculus, you'll say, oh, I remember this stuff. And it'll be a little easier the next time you hit it. So, woohoo, congratulations, you're amazing and awesome. And I'm very proud of you. Go get something to drink, come on back, and let's do hyperbolas. Yay! Math on.